Hey everyone, I have a confession to make. Coming from an Azure background, AWS authorization had me confused for a long time. In Azure, it's pretty straightforward. You have RBAC where you assign roles to users or groups, and that's pretty much it. But in AWS, there's IAM users, there's IAM policies, IAM roles that users can assume, which means users can temporarily become a role to get different permissions. Kind of like putting on a different hat each time you assume a different role. But then there's also IAM roles with policies attached into them. And you can put policies directly on resources like S3 buckets or even on KMS keys or VPC endpoints, as we'll find out shortly. I kept asking myself, which is which? When do I use one versus the other? It felt like there were so many different ways to control access, and I wasn't quite sure which one I should be using. And then there's the networking side, private connectivity, VPC endpoints, interface endpoints, gateway endpoints. What are all these things, and when do you use them? Here's the thing, both identity management and network security are fundamental building blocks for something called zero trust architecture. If you're working in enterprise environments, you absolutely need to understand how these work together. So today I'm going to walk you through a hands-on demo that shows exactly how AWS authorization works. We'll build a demo environment that approximately costs 20 cents per hour to run. So that's not too bad. And I'll show you 3 different stages of security, from the default access, which is somewhat secure, all the way to a fully locked down zero trust setup. By the end of this video, you'll understand how AWS manages access control and why combining identity restrictions with network restrictions is so powerful.
Okay, what are we building today? We're going to deploy this Terraform code that builds our environment. But before we do that, let me just show you this diagram so you get a better idea what we're deploying. It will consist of 3 stages. The first stage is on the left here, where we have the most basic security, and it's only using IAM permissions from the user side of things. You can see in this stage 1 diagram, it's all on the internet. When we deploy the S3 bucket, so this S3 bucket is the resource that we want to protect. When we deploy this S3 bucket, the only control we have is IAM permissions from what I'm going to test is from my admin laptop, as well as from this EC2 that is publicly available. So the next stage, stage 2, has network restrictions. This dotted line here is your network boundary or network perimeter, where I still have my EC2 that we've used in stage 1 that is publicly accessible, and it goes out to the internet to try and access the S3 bucket, but now it can't. And that I've spun up another EC2 instance that is in the private VPC. The only way for it to make calls to the S3 bucket is via this VPC endpoint. The S3 bucket will have some protection around it in terms of this EC2 instance, or whoever is calling this S3 bucket must have permissions to the S3 bucket, as well as the S3 bucket has some configuration saying that I will only allow access to come from VPC endpoint. And that's why my public EC2 instance won't be able to make calls to the S3 bucket. And then lastly, moving to stage 3 is where we still have that network boundary, but we add another layer with only a specific role being able to access the VPC endpoint. We have two instances here, A and B, and only A will be allowed to access the S3 bucket. Even though instance B is accessing the S3 bucket privately through the VPC endpoint, it won't be able to. So I've logged into AWS and I'm ready to apply my Terraform template. I planned it first and now I'm gonna apply. And while it's creating the resources, let's just have a quick look at the Terraform template. You see here we're defining the EC2 instance AMI. We're defining the VPC to use. This is for my stage 1 and this is the publicly available EC2 instance. It's using the default VPC and the default subnet. I'm also creating the S3 bucket, which has no configuration. It's just the out-of-the-box bucket with a name. It's got some IAM roles in there for the public instance to be able to access the S3 bucket. As you can see, it's got get object, put object, and list the bucket, and it's attaching the policy in there. It also needs permission to access my EC2 instance from my laptop, which in my case, instead of SSH, I'm using the session manager, which is more secure because I don't need to use a key, SSH key or SSH password. I'll skip the rest for now and we will go look at the deployment, which is now done. Okay, so let's have a look at our bucket. I've got these two buckets. At the bottom, the demo bucket and the demo logs. This is where I've configured my S3 bucket to send server logs over to this logging bucket. As you've seen in the Terraform template, this contains the default configuration with the exception of server access logging, which will be handy for troubleshooting. And I've used it for troubleshooting a lot. And this is what we'll be interested in, the bucket policy. So at the moment, there's nothing in here. Okay, now let's connect to our EC2. First, we'll try it from our public instance. Actually, now that you've seen the S3 buckets, we'll go back to this console where I'll just capture all these outputs from the Terraform deployment. This is what we'll need to form and construct the S3 bucket policy for the next stage. So for now, I just want to test from my Mac, which I'm coming from the internet, to show you that if I do an AWS S3LS, I can see that there's a folder called unsaved in there. And that's the only content of that S3 bucket. I'll create this test file called testpublic.txt and copy that over to the S3 bucket. As expected, it will work because if I do an AWS STS get caller identity, this role that I'm assuming is the admin role, administrator access, and it has by default full access to all the S3 buckets in that account. So that's how I'm able. Now let's try and connect to this public instance. And you've noticed I'm using Session Manager. As I mentioned earlier, there's no SSH keys needed because Session Manager users are IAM credentials instead of SSH keys, which is already a security best practice. So first off, I'll show you the role that we are using here. AWS STS get caller identity. As you can see, this role, Zero Trust Demo Public role, that's the role I showed you earlier in the Terraform template with the get bucket, list buckets, and which allows me to upload objects into the S3 bucket. We'll copy a test file over. So this is just changing directory to the temp tmp directory and creating this test stage1.txt file, copying it to our S3 bucket. And that worked as expected. Let's have a quick look at the S3 bucket. We've got the test public, the test stage, and an unsaved folder in here. Perfect. Both uploads worked. At this stage, anyone with the right IAM permissions, as you've seen, can access our S3 bucket from anywhere on the internet. So going to the next stage now, stage 2, where we are adding our first layer of zero trust security, which is network restriction. This is where things get a little bit interesting. I'm gonna just grab some details from my admin role. You notice here just doing a AWS get caller identity and getting the user ID part of it, the ARN part of it, just to construct the S3 bucket policy so that I won't lose access. Me as the admin won't lose access to the S3 bucket from the S3 console. I'll now apply the bucket policy by applying this code. This will make more sense when we see it on the S3 console. So that's done. Let's go to the permissions. And now we have something here in the bucket policy. So this policy statement is a set of allow and deny rules that we define on the bucket. This controls what and who can access this S3 bucket. So this is written in JSON format. And this first block of the statement, we can already see the effect is allow me, the admin role, from anywhere. We're saying allow this assumed role to access the S3 bucket and give it full access. This S3 colon star is a wildcard, which means any actions on the S3 will be allowed. And you scope it to the bucket. So this is the bucket ARN with /* in the end to indicate all the contents as well. So this is the bucket itself, and /* is all the contents or all the objects within the bucket is included in this scope. That's how I continue being logged on as this admin to have access to see the objects in the S3 console, even coming from the internet. But if you're in an enterprise environment and you require this S3 bucket to only come from private access, then you'll have to adjust the permissions bucket policy here. The second block is deny all other access from the internet. And this is an explicit deny saying that any principal, meaning any identity, won't have access to this S3 bucket. So it's scoped again to the bucket and to the objects, except if the user ID matches this. And another exception is that it uses this VPC endpoint. What is this VPC endpoint? Go to VPC. You'll see a whole bunch of VPC endpoints here. And this ending in D70 is the one that we've defined, or is the one that we've used in the bucket policy definition. We're saying we're only allowing any access to our S3 bucket if it's coming from this S3 gateway endpoint. In case you're wondering what is a VPC endpoint, think of your VPC, which stands for Virtual Private Cloud. Think of it as your private office building and the internet as the public street. Normally, to reach AWS, like S3, your traffic has to go out to the public street and back. A VPC endpoint is like having a private tunnel directly from your office building to the AWS service. There's no internet required. And there's two main types of endpoints. One is the gateway endpoint, and the other one is interface endpoints. Gateway endpoint is what I used here because A, it's free. It's a free option available, but it's only available for S3 and DynamoDB. These work by adding routes to your route table that redirect traffic through AWS's backbone network instead of the internet. I'll show you this diagram, which hopefully will make it clearer. So this is the gateway endpoint. What happens is with this gateway endpoint is that from my private EC2 instance, it will need to know how to get to this gateway endpoint. Without a route saying that for my S3 traffic, use this VPC endpoint, which is a gateway endpoint, it won't know about this. And you can see the domain here is that it's s3.region.amazonaws.com. If we look at the console, you can see here that it is mapped to this VPC. This is the region and this is the service name, which is the reverse, com.aws, AWS, which is, this is the region and S3 being the service. If we look at route tables, this route table has the default local, and this is the important bit. This is the private link, PL, that you need to include in there so that my private EC2 instance now knows to use this S3 gateway endpoint when it tries to reach this service name. So what are these other endpoints that I've deployed? They're used for Session Manager. Because my EC2 instances don't have internet access at all, they need to use VPC endpoints as well. And you notice there's also this EC2 endpoint. So these three endpoints, EC2 messages, SSM messages, and SSM endpoint, they're needed to connect to my private EC2 instance without my EC2 instance having any internet access. And for my private EC2 instance to know about the AWS service, what happens here is they actually insert an elastic network interface, or an ENI, right into your subnet with a private IP address. So no routing required. It uses private DNS, as we can see here in the console. For example, this SSM endpoint. Again, it is linked to the private VPC. There's a DNS record type, and there's 3 of these private DNS names. So it creates these private DNS, and it's all taken care of by the VPC service for us. We don't have to do anything more. You need to map this to the subnet so that it knows where to create that elastic network interface for you. You can put some security groups in there as well. Another thing to note is that this will cost you around 1 cent per hour per availability zone. Okay, time to test our access in stage 2 after we've applied that bucket policy. This is my public instance, and if I try and do the same thing of uploading the file to my S3 bucket, we expect it to fail. And if we look at the error, an error occurred when calling the put object operation. It's because this user is now not authorized to perform, because there is an explicit deny in a resource-based policy. So these two are important to highlight here. Explicit deny, let's go back and have a look here. This is the explicit deny that it's referring to, and it's a resource-based policy, which means the policy or the control is set on the resource, which is the S3 bucket that we're trying to hit, this guy here. Now I will try to access from my private instance. I'm gonna do a similar thing, which is moving to the TMP folder and creating a test file called testprivate-stage2.txt, copy that to the S3 bucket, and that worked as expected. Okay, to recap, this worked because the private instance is configured to route its S3 traffic through our VPC gateway endpoint for S3, and the routing table automatically sends the S3 request through the private AWS backbone instead of the internet. When it hit the S3 bucket, the S3 bucket policy says allow access if you're coming from the VPC endpoint. We've implemented network-based access control here, and it doesn't matter if you have the right IAM permissions. In this stage 2, we've implemented network-based access control. It doesn't matter if you have the right IAM permissions, like my public EC2 here has the permissions to access S3, but because the bucket policy explicitly denies all access except if you're coming from the VPC endpoint, or like in my case, I'm the administrator and I'm allowed to access from the internet. Now for the final part, which is stage 3, we're going to add identity restrictions on top of our network restrictions. We'll be testing from 2 EC2 instances within the same VPC, and both use the VPC endpoint. But this is a realistic scenario where you might have a web server. Let's pretend this is a web server that needs access to this protected resource. It can be an S3 bucket, it can be a database, and you have another web server here which doesn't need access to this S3 bucket. So you have to only allow this web server. We will now see how we can implement that using S3 bucket policy. So for stage 3, we'll come back to our terminal. I'm just again constructing the variables needed to create the S3 bucket policy for stage 3. It will make more sense once we see the S3 bucket policy on the console. For now, I will hit apply on this one. Let's review what happened with this stage 3 bucket policy. Again, it has the same allow admin from anywhere, but we have as our second statement a new allow statement, allow role AF only from VPC endpoint. So this explicitly says only the EC2 that assumes this role. So it doesn't have to be an EC2, right? It can be a group, it can be a user that assumes a specific role. So just for this demo, I'm using an EC2 just for simplicity. We're saying allow this principal any action on any S3 actions rather, and scoped it to this bucket and its objects, and use this condition that it has to come from this VPCE. And lastly, my deny all other access is saying this is where we explicitly say that if you're coming from the internet, or regardless of where you're coming from, whether it's the internet or the VPC, if you're coming from this instance, so this is the assumed role of that instance, take note of this, it's ending in 1BEB, then you're explicitly denied access to this S3 bucket. We're now in our EC2 instance A. I will do the AWS SDS get caller identity. It's using this zero trust demo role A. If we do our test, we're gonna upload this test private A stage3.txt file to the bucket. And as expected, it worked. Now going to private instance B, we're gonna upload a file called test private B stage 3. As expected, it failed. And it has a similar error to the one we encountered when we tried uploading from the public instance. It says the same thing here. There is an explicit deny in that resource-based policy. That's because our zero trust demo role B is being used and you're coming from this particular instance. If I do an AWS STS get caller identity, I can see that this is the instance that I'm using versus if we go to our demo A, it ends in 1BEB. Going back to our bucket policy, this is where we have our explicit deny statement, and we're saying no one can access, is not allowed to do or to perform any S3 actions on this bucket and its object, except string not like, except if your user ID is this, which is my admin role, or this one here, which is my EC2 instance role A. Just wanted to share this with you about the differences between Azure RBAC or role-based access control and AWS IAM authorization model. On the left with Azure, you only need to apply it on the user, so it's user-centric. You give it a role, whether it's a storage contributor for access to a storage account, and you give it a scope. You can apply it at the highest level of management group, description level, resource group level, or the actual resource, which is can be the storage account. And that will give your user or your group access to that particular resource. Versus AWS has a multi-layer way of applying it. Your first layer would be your user. Your user needs access and it gets this through a role policy. Then your second layer, which is your resource, it can be your S3 bucket policies, it can be KMS. Then you can have another layer, which is your VPC endpoints, IP conditions, security groups. And the combination of that is what you can play around with to manage access to a particular resource or service. I also want to share with you that not only can you put it on the identity level, so we've applied it on our identity or role that we're assuming. We've also applied it on the S3 bucket, but we can also apply it on VPC endpoints or, as I mentioned, KMS keys or any other resource. There's this tab here called policy, and it's structured very similarly to a bucket policy, and it's called a VPC endpoint policy, controlling access to the service. So we can add a policy here to say that our VPC endpoint will only allow these specific roles to use this endpoint, or that this endpoint can only access buckets starting with, for example, prod dash as a prefix. And you can even add time-based restrictions like only during business hours. For our demo though, I kept the VPC endpoint policy open to keep things simple. However, in a real enterprise environment, you'd likely be restricting this as well. Now, I just wanted to share a little bit about server access logging. If you click this link, learn more, it will teach you how to set this all up. And this is basically what I followed, so that you can query and look at what has been accessing your S3 bucket. So I've already set up Athena. We will go to there. I just wanted to quickly explain for those wondering what is Athena. So we're here in the Athena console. I've set it up. I've set up the database and the tables per the documentation that I will provide the link. So I just wanted to briefly explain, in case you're wondering what is Athena, that it is a serverless query service that lets us analyze data directly in S3 using standard SQL. So you don't have to worry about managing a server, and you just pay per query. And this is my SQL query, which just selects these columns from this database and table that I've created. And I've filtered it to the operation being just the put calls. And here it is. So we can see that the request date time is in UTC, which you can change in your SQL query to your local time zone if you prefer. But the interesting bits here are the calls that we've made. So we started off from this remote IP. If you remember, this is my max public IP, and this IP address starting with 3.107, these two are from the public EC2 instance. This 10.0.1.38 is my private instance A, and this 10.0.1.120 is my private instance B. You can see the requester ID. This is my admin role. This is the public EC2 instance role. This is role A for the EC2 instance, and role B for that private EC2 instance. Scroll further, we can see the files that we've attempted to upload and the HTTP status, 200 for OK and 403 for access denied. So this is when I tried it again after we've set that bucket policy coming from the public EC2 instance. So this public IP address, after we've set the bucket policy to only allow access from the VPC endpoint, I got this access denied. Then we tried it from the EC2 instance A and B, and that worked fine. Except when we've reached stage 3, where we explicitly only allowed the private access as well as EC2 instance A, then when we tried accessing from EC2 instance B, we got that 403 access denied.
I hope this cleared up some of the confusion around AWS authorization. The key insight is that AWS gives you multiple layers of control. There's identity, there's resource, there's network, and true security comes from combining them thoughtfully. Thanks for watching, and I'll see you in the next video.